Temperatures are rising, and one colony of ants will soon have to make a collective decision. Each ant feels the rising heat beneath its feet but carries along as usual until, suddenly, the ants reverse course. The whole group rushes out as one. A decision to evacuate has been made. It is almost as if the colony of ants has a greater, collective mind. A new study suggests that indeed, ants as a group behave similar to networks of neurons in a brain. Rockefeller's Daniel Kronauer and postdoctoral associate Asaf Gal developed a new experimental setup to meticulously analyze decision-making in ant colonies. As reported in the Proceedings of the National Academy of Sciences, they found that when a colony evacuates due to rising temperatures, its decision is a function of both the magnitude of the heat increase and the size of the ant group. The findings suggest that ants combine sensory information with the parameters of their group to arrive at a group response, a process similar to neural computations giving rise to decisions. This is one of the first steps toward really understanding how insect societies engage in collective computation. A new paradigm at its most basic level, decision-making boils down to a series of computations meant to maximize benefits and minimize costs. For instance, in a common type of decision-making called sensory response thresholding, an animal has to detect sensory input like heat past a certain level to produce a certain costly behavior, like moving away. If the rise in temperature isn't big enough, it won't be worth it. Kronauer and Gal wanted to investigate how this type of information processing occurs at the collective level, where group dynamics come into play. They developed a system in which they could precisely perturb an ant colony with controlled temperature increases. To track the behavioral responses of individual ants and the entire colony, they marked each insect with different colored dots and followed their movements with a tracking camera. When they increased the size of the colony from 10 to 200 individuals, the temperature necessary to trigger the decision to vacate increased. Colonies of 200 individuals, for example, held out until temperatures soared past 36 degrees. They use a mathematical model to show that such a mechanism is indeed plausible. But they do not know why larger colonies would require higher temperatures to pack up shop. In future studies, Kronauer and Gal hope to refine their theoretical model of the decision-making process in the ant colony by interfering with more parameters and seeing how the insects respond. For example, they can tamper with the level of pheromones in the ant's enclosure or create genetically altered ants with different abilities to detect temperature changes. In the long term, the idea is to reverse engineer the system to deduce its inner workings in more and more detail. Asaf Gal, Daniel J. C. Kronauer. The emergence of a collective sensory response threshold in ant colonies. Proceedings of the National Academy of Sciences, 2022, 119, 23, doi. 10. 1073, PNAS. 2123076119 Rockefeller University. Ant colonies behave like neural networks when making decisions. Science Daily. Science Daily, the 22nd of July 2022. ift.tt/Kudlich. Rockefeller University. 2022, July 22. Ant colonies behave like neural networks when making decisions. Science Daily. Retrieved July 22, 2022 from ift.tt/Kudlich Rockefeller University. Ant colonies behave like neural networks when making decisions. Science Daily. ift.tt/Kudlich, access July 22, 2022. Thanks for watching. Please subscribe my channel for more videos.